So in the last few sessions, we talked about topics, partitions, brokers, controller brokers, where the producer will come into picture. There are some more things we have to discuss here, that is replication. So today we'll discuss on a bit on the replication. Now what is replication? Now what you can do here is you can say topic is sensor, partition is 3. You can say replication 2. Two replications we can say here. Now when we say two replications, what it means here is your partition will be replicated two times. There will be two copies of each partition. So let's say we have sensor hyphen 0, sensor hyphen 1, sensor hyphen 2. So we have three partitions of our sensor topic. Since the replication is 2, there will be two copies of each partition. So this usually is called as the original we can think of as a leader copy. All these are called as leader copy. Original copy you can think of. So Kafka uses a jargon called leader copy. And it will have one more copy now. We'll call that as a follower copy. A sensor 0, again to one more copy, we will call it as a follower copy. There can exist sensor 1 follower copy. Let's say there is one more sensor 2 follower copy. So that's the replication. As you can see, there are two replications of sensor 0 top partition, two replications of each partition. And the replication is used for durability purpose. But the communication always happens through the leader copy, or you can say the communication always happens through the broker which hosts the leader copy, which is responsible for the leader copy, meaning the producer will send the messages to broker 2, it will send the messages to broker 4, it will send the message to broker 5. The producer will not send the messages to broker 1, broker 3, and broker 6. So that's how the architecture works. If we have a consumer here, let's say we have a Spark streaming. So obviously the Spark streaming will have a consumer embedded inside that. The consumer will only consume will send the request to the broker to send the data, and it will ask for the data. So it will send the request only to broker 2, it will send the request to broker 4, and it will send the request to broker 5. And in that request it will ask for messages, and the broker will send the messages to these consumers. That's how the things work. The follower copy or the replication is only used for durability purpose. Now how data is again copied into these follower copy. So what happens? So they also act, these follower brokers, They also act like consumers, but the inside internal consumers, inside the Kafka cluster consumers. What they will do is they will request. So sensor hyphen zero topic is replicated in broker 3. Broker 3 will send a request to broker 2 and ask for the newly received messages. And broker 2 will send the newly received messages to broker 3, and broker 3 will update those messages to its file. In a similar fashion, in a similar fashion, broker 6 will contact broker 4 and it will ask for the newly messages that has arrived. Broker 4 will send those messages to broker 6, just like broker 2 used to send the messages to broker 6, and broker 6 will write to the file. And the same way broker 2 will ask for messages from broker 5, and broker 5 will again send the messages that it has received from the broker 5, and broker 1 will write into its partition. So that's how replications are maintained. Producer does not send the messages to the replications, or the brokers which host the replication copy. It is through the broker itself. Broker to broker communication happens. So I hope that was clear. That was clear how they maintain the copy here. Now, as I said again, the communication always happens through the broker which hosts the leader copy. Sometimes we call it as a leader broker. This is what I wanted to say. You call a leader copy or a follower copy. Sometimes people also say leader broker, meaning a broker which hosts a leader copy is a leader broker. Here you can have any number of topic partitions. Here you can have add logs to something, add logs one something, add logs zero here. So all this could be a let's say this is a follower copy. This is also follower copy. This is also follower copy. Then we can have add logs zero. This is a leader copy. Again we can have add logs one. This is also leader copy. Again I can have add logs two, which is a leader copy. So as you can see here, so broker two hosts follower copy for add logs topic partition 2, and leader copy for sensor topic partition 0. So you can imagine, like, sometimes people also call brokers as leader broker or follower broker. So broker 2 is a leader broker for sensor topic 0. It is a follower broker for add logs 2. So it can be a leader or it can be a follower for based on with respect to a partition. So in which case it will be sending, if it is a follower, it has to get the data from the leader and update its message logs. So that's how the things work. So I hope the leader copy was clear and the follower copy was clear here. So I assume it is clear, and I will move on to the next part. Now, what happens if a broker goes down? What happens if the broker 2 goes down? Obviously, the communication for sensor will stop. The sensor communication will stop because it is hosting the leader copy, and the communication from the producer to the consumer will stop because the broker is 2. Producer will not send the messages to the messages messages to the replication broker. I mean to say follower broker. It always sends the messages to the broker which is hosting the leader copy. So obviously the communication will stop. So the communication must not stop by any case. So how we can make sure that there is always the data pass happening from the producer to the consumer. Data is being transferred. So again zookeeper comes into picture here. So if you remember, we had one of the broker will be a controller broker. Let's assume that broker broker one is the controller broker. We also saw that there is one more directory created brokers, inside that one more directory IDs, and a dummy files 1, 2, 3, 4, 5, 6. Now as I said earlier, the controller broker the controller broker will subscribe to this directory, meaning any change happens to this directory, the controller broker will get a notification. So as soon as broker 2 is down, the TCP connection between the zookeeper and the Kafka will between broker 2 and the zookeeper gets disconnected. As a result, this dummy file is deleted from the IDs. We have seen this. We have seen this. Meaning broker 2 is not up. Now broker 1, which is the controller broker, it will come to know that broker 2 is down. Broker 2 is down. Now controller broker also knows that that was hosting the leader copy for sensor topic partition 0. Now broker 1 also knows that where the follower copy exists for that. So follower copy is nothing but broker 3, and it has the data replicated in its disk. The data is replicated there. Since the data is available there, broker 3 will be made as the leader copy. I mean leader for sensor hyphen 0. So if so let's put it in a only one thing. A broker may host many leader copies. We can have sensor hyphen 0, I mean to say uh, add logs 2, clicks partition 5. Some many leaders copy could be there. Meaning this broker is responsible for all the read and write operations on these topics. If this broker goes down, some other broker has to be chosen as the leader broker so that the communication does not stop. So all this information is with the controller broker. Controller broker knows where a follower copy exists for sensor hyphen 0, add logs partition 2, and clicks partition 5. All those metadata information is known to the controller broker. As a result, those brokers are made as the leader broker for for all the partitions that were there in the broker which has gone down. So some other brokers may be there. Let's say let's say this is broker 2. Let's say broker 3 had sensor hyphen 0. It was a follower copy. Broker 4 had add logs 2, which was a follower copy. Broker 5 was there with add logs, no, clicks 5, which was also a follower copy. Now in this case, all broker 3, broker 4 and broker 5 will be chosen as the leader copy. So leader election will happen. So in that case, the producers. So we have a sensor producer, we have a clicks producer, we have ad logs producer. All these producers were sending the messages to broker 2. They were sending the messages to broker 2. Now since the broker 2 is down, broker 2 is down, after as soon as the broker 2 is down, so the communication happens through the zookeeper, the broker election happens again, zookeeper comes into picture, broker election happens, broker 3 will become the broker which will be now making this as the leader copy. All these information will be metadata information. Now the communication should happen through broker 3, broker 5, 4 and broker 5. How does producers comes to know that these are the new brokers where the communication has to where we have to send the messages. Now since broker 2 is down, so they will get an exception called leader not available. So they will get an exception, leader not available exception. Once they get this exception, they will send the metadata request once again. These producers will send the metadata request once again, and they will get the updated metadata request. They will get the updated metadata request, and from that updated metadata request, they will come to know that broker 3 is the leader for sensor 0, broker 4 is the leader for add logs 2, and broker 5 is the leader for clicks partition. So sensor producer will now be sending the messages to this. Then it will send the messages. Add logs will send the messages here. Clicks producer will send the messages here. So that's how it is made sure that always the communications will be there. There will be always communication. The communication should not break in case of the real time processing, because that's what the main thing in the real time processing. You should be continuously getting the data. If one of the broker goes down, there will be no continuous data available. So that we have to always make sure, and all these things are taken care internally. As a developers, we don't have to do anything, we don't have to write any code here, but it is good to it should be understood. It is all done by the Kafka framework itself. So one more point to remember about zookeeper is, I think I one more point to remember about the zookeeper is it it helps in leader election. It helps in the controller broker election. It helps in the leader election. It it helps to know the membership of the cluster. I think to one more point we had, I don't remember that, but that's all the high availability of the we can think of a controller broker, as well as high availability of the leader brokers. We can leader elections, or we can say high availability of a leader broker. So those are all the use cases of, I mean, Zookeeper is usually used for that purpose. And Zookeeper it itself is highly available. You don't need any other framework for high availability of the Zookeeper. Zookeeper is again a distributed framework, and it itself is a highly available always. It will be running on a multi-node cluster. It will be choosing its own leaders and followers. In Zookeeper also there is concepts of leaders and followers, and it itself will choose it itself is highly available always. So I hope replication was clear. Why replication is being used? It is it is used for not to break the continuous data flow from the producer to the consumer, with the help of Zookeeper and some concepts like leader copy and follower copy. So I hope it was clear. Sometimes what happens, sometimes what happens, so you can have, usually for high durability, replication is made as 3. Let's say we have partitions we can have more. I mean, it depends on your data flow. Computation of number of partitions or calculating how many partitions you want, it's again some mathematics we have to do, some calculations we have to do. So let's assume that we have 4 partitions. For very high durability, we will have usually 3 replications. So you will have a sensor -0. So 3 copies of your each partition will exist. So one will be the leader copy, other two will be the follower copy. So let's say this is broker 1, broker 2, and broker 3. Broker 1 will be sending the request, and it will ask for latest messages. Broker 1 will send the messages to broker 2. In a similar fashion, broker 3 will also ask messages, and broker 1 will send the messages to broker 2. And they will write those messages to the corresponding files. So it is usually 3 replications for high durability. Now con- when the leader broker goes down with respect to sensor partition 0, which is broker 1 here, one of either of broker 2 or broker 3 will be chosen as the leader. Whoever has the latest messages, most recent messages, that broker will be chosen as the leader. So that's how the replications are useful. So I hope replication was clear, and I hope leader copy was clear, and the follower copy was clear. Now, keeping these in mind, let me showcase one example. Let me showcase an example of how to write a producer code. So you can use, there are a lot of producer example code here. You can go to downloads, training, Kafka, Kafka examples, and producers. In this there are a lot of producer examples, but what I will show is I will showcase a simple log analysis that I'm generating. It will look much better. You can open the log analysis code base, and there we are writing our producer. I will showcase a simple producer, then we'll see an Avro producer, because we have to understand what is the Avro file format. So here is our producer, a simple producer. And whenever, this is where you write the code, this is where you write the code. And on the producer side, there are three mandatory configuration settings has to be done in the producer. The three configuration settings are bootstrap server. We already know what is a bootstrap server configurations. This is where you specify the IP address of the brokers, just for the producer to know where your Kafka cluster is running. This configure, the name is a bit confusing, like bootstrap server, but it is all the broker servers. Just for the producer to know where your Kafka cluster is running. Obviously, we have to specify the IP address and the port. Usually, at least two brokers' IP address has to be specified, that we have discussed. And also there should be key serializer and value serializer. Now, what is key serializer and value serializer? Kafka only understands the data in the form of bytes. Kafka doesn't do any validation what kind of data it is. It will store the data as bytes, and everything will be treated as bytes. So if there is a Kafka, we have our producer here, we have our consumer here. So the data will be in form of bytes. The data that will be stored here is as bytes, and the data that will be sent to the consumer will be in the form of bytes. So it will be always in the form of bytes. So it doesn't mean that we have to send bytes. It doesn't mean that we have to send the bytes. So that's where you can send a string also. The producer can send the messages as string. The producer can send the messages as JSON. The producer can send the messages as class objects. Any way it wants, it can send the messages. Those messages are converted to bytes using the serializers. So that's where the serializer comes into picture. And the same way for the consumer as well. So there will be deserializer here. So bytes will be converted to whichever format it was serialized. So if you are sending a string, so string will be serialized to bytes, and those bytes will be sent to Kafka. When the consumer asks for messages, Kafka will send the bytes. Those bytes will be deserialized to the string, and the consumer will get the messages. So those things are mandatory. So if you are sending a string message, so you need to use string serializer. Again, Kafka sends the data in the form of key value messages. The messages are in the form of key and value. And your actual message will be the value part. When producer sends a message, the message will be in the form of key and value. Value is your actual message. Usually nothing will be there in the key part, but sometimes you can also make sure to you can put something inside the key also. But most of the time, your actual message will be in the value part of your messages or events sent by the producer. So I hope the things are clear how the messages are being sent. Now just to showcase a example, as I said, these are the three mandatory parameters. Now we are creating a producer object here. We are creating a producer object, meaning this, and we are saying string comma string, meaning the key that we will be sending is a string, and the value we will be sending is also a string. That's what we are creating a producer. This is a producer object whose key data type is string and value data type is also string. That's what we are saying. And we are creating a producer here. Using these properties files, we are creating a Kafka producer whose key is string and the value is also string. So once we have this producer object, we can send the messages. So there is a method called send. There is a method called on the producer object. There is a method called send, and you can send a record. Whatever record you want, you can send. So the record will be in the form of producer record. So you have producer object. So you have producer object. It has a send method, and you will send producer record. Your actual record will be wrapped inside this data structure, producer record data structure. Producer record data structure is again in the form of key and value. So you can see here is our producer record. And as you can see, this method is again called, this is the Kafka method. Everything else is our own methods, a wrapper producer code. The only Kafka method is the producer.send. This is our wrapper function, our own wrapper function. So it is being called here. It is being called here. As you can see here, there we are creating our new producer record from our actual message. So this is our actual message, and we want to send the data to this topic. Some topic, whatever topic we want, we can send it. Our actual message and our topic, and we create a producer record, and that producer record is being sent to the Kafka cluster. And publish is the method that is exposed to the client API. This method is exposed to the client application. So here I have written a simulator program. I have written a simulator program which generates Apache logs. Which generates Apache logs, and this method is exposed to that generator. Apache log generator Kafka. If you see, if you open that, so there we are calling that publish method, and publish method will send our Apache log events to this method. So this method will internally create a producer record, and that producer record will be sent to the Kafka cluster. So that's how you write a producer code. So let's run this program and check the result. To run this program, we need to set up our we need to start all our servers. So we'll go to the Confluent and say Zoo. As we know that, as we now know that Zookeeper is always required for the Kafkas to start. Kafka depends on Zookeeper for lot of stuffs. So first we have to start Zookeeper. Zookeeper server start. Properties we have to give it etc Kafka properties producer dot properties. Sorry, what I'm giving here. Zookeeper dot properties. Let's open one more terminal. Let's start the Kafka broker as well. Kafka server start etc Kafka server dot properties. Our Kafka server is also up and running. Let's open one more terminal and create a corresponding topic so that our Apache log messages will be there. I will give the topic name as Apache log. Apache log will be the topic name. So we are specifying a partition as 3. Partition as 3. Let's go and check whether 3 folders has been created or not. So we can see here all the 3 folders are created. So let's go and check inside these folders. So as of now the size is 0. As of now the size is 0. Let's see how it looks like. Tail F. We will just do a tail because let's see, as we send the messages from our producer, it will get appended here, and tail will always show the appended data to this file. Let's do it for all the partitions. We'll go to Apache -1 tailf dot log, and one more Apache -2 tailf Let's tail on all the three partitions just to check whether the data is coming to our cluster or not. So let's run this program, Apache log generator. So Apache log generator, let me see where I'm specifying the topic name, and the bootstrap server will be passed as a parameter. Topic name we are passing as a parameter. Most of the things we are passing as the parameters. So we are passing three parameters: number of records per day, how much records I want to generate per day, all the bootstrap servers, and and the topic name. We can put all those things in a configuration file and read it from there. That also I will showcase. So we want to run Apache log generator. So the number of records I want to generate per day is 86,400. So which will boil down to one record per second. This is where our broker is running. Usually you need to specify at least two. Since we are running on a single system, we are just specifying one bootstrap server because there exists only one server. And we have to change this as per what we have created here. Apache log is the topic that we created, so our messages we will be sending to this topic. Let's run this program. This should start sending the messages to the Kafka cluster. Meanwhile, let me check one thing. So I had written down how the number of partitions should be, how to create the number of partitions. Let me check where I have written that calculation. let me recall that. I will explain that as well. How to, okay, exception, null, found exception. I don't know these errors. Why these errors I'm getting? I really don't understand. So as you can see, this is how the messages are being generated. Since I gave 86,400 messages per day, so which will boil down to one message per second. So one message per second is being generated. Continuously the messages are coming. Let's check whether it is going to the Kafka cluster. So we had done a tail, right? So it is coming here as you can see. This is partition 0, partition 1. Here also we are getting messages, and here also we are getting the partition 3. So that's how you have to write a producer code. Three mandatory parameters or configuration parameters: bootstrap server, key serializer, and value serializer. So I hope the producer code was clear. You can write any logic there. How you want to send the data, you can send the data as a JSON object, then serialize your JSON data. Now we need to learn some more things about the cluster. I mean, I will just give a rough idea. I just don't remember the number of partitions. How to how to determine number of partitions. I mean, this is again you need to uh, do some experiments here. It's not a straightforward. You have to have some starting point to determine the number of partitions. So I think somewhere around 10K messages per second per partition. I don't remember this, whether this is the thumb rule. I think it's 10K, somewhere around 5K or 2000 events per second. I don't remember. Let me go. Where do we specify the number of partitions? While creating the topic. So while creating the topic, we specify that. Create topic, if you remember the command. So when we create the topic, Kafka topics, I want to create sensor topic, and we'll say replication factor and partitions. So this is where we create the number of partitions. but how many partitions we need to specify, that is a bit of a tricky thing to come up with. You can just imagine 10K messages per second per partition. That's the thumb rule. When we say thumb rule, it is not the perfect one. It could be taken as a it could be taken as the starting point. Now let's say your application. From your application, you are getting messages at the rate of at the rate of 10 MB per second, sometimes 1 GB per second, 1 GB per second, and this is one thumb rule. And the message size around 2K. This is one more thumb rule you have to keep in mind. Or I am just confused here. Sometimes I will dig a bit more. Whether it is 2K messages per second and 10K message size, I don't remember. Whether it is 2K messages per second per partition and 10K as the message size. Somewhere I'm missing something. But let's have either of this. Final computation will result in the same thing. So if you are having 10K messages per second per partition, and you must have around 2K messages per second, so how much you have to multiply these two? 2K into 10K. How much you will get? 2 into 1024 into 10 into 1024. How much it will get? I am not good here. 2 MB. Is it 2 MB or 20 MB? Let's say we get it as 2 MB. 2K into 10K. Right. I mean 1K into 10 is equal to 1 MB, right? Then is equal to 10 MB, right? So we can imagine in this way. So if you take the calculation in this time, 1K into 10 is equal to 1 MB, we know that. So obviously 1K into 100 is equal to 10 MB, 1K into 1000 equal to 100 MB. So that's not so. The calculation somewhere something is happening. So 1K into 10,000 equal to 1 GB. So I mean to say 1K into 10K, it comes to 1 GB. There is something wrong here. One partition, one partition is trying to handle 1 GB. Let's there is a there is something wrong in the calculations. Let me rectify that. 1K into 10K is 1 GB. Yeah, it will be 20 GB. That's the wrong thing. 1K. Right, Samir. That is 2K into 10K comes to 20 GB. So then the whole thumb rule goes for a toss. There is something wrong here. I think it is, sorry, not 10K messages. It is 10,000 messages. 10,000 K messages, not my mistake. It is 10K is nothing but 10,000 messages only. If I have 1,000 messages per second, which comes to 100 MB, 200 MB. That is also, it should not be handling. 100 messages per second, it's too less. Let me get on this. Somewhere around it has to come around, uh, let's say 10 MB per second per partition. I mean, it should come around this. Our calculation should come around, so 10 MB to 50 MB, 10 to 50 MB per second. It should not, a partition should not be handling more than this data, one partition. So if your throughput is 1 GB, if your throughput is required to be 1 GB per second, which would be very rare, 1 GB per second, so how many partitions we would require? So it would require around, if let's say if it is 50 MB, 50 MB is per partitions, 50 MB is per partition, 100 MB will be 100 MB will be two partitions, so 1000 MB is nothing but 20 partitions. So if you want to achieve a throughput of 1 GB, so you need 20 partitions. It all depends on what is your input rate, what is your throughput rate, how fast you are getting the data. So if you are getting around 1 GB of data per second, so in that case, uh, these are the partitions you need to have. I think more than that will be there. I mean, somewhere I am missing something, but you have to have a thumb rule on some messages and a message size. X messages and message size is some YK bytes. This I have to come up with. It all depends on how many messages you are getting per second and what is the message size. So based on that, I think each partition should be capable of handling 100 MB. Or sorry, 10 MB. If it is 10 MB, so it will be 200 partitions. For 10 MB, for 10 MB per second, it will be 200 partitions. For if at all you want 50 MB per second, if you are saying that one partition will handle 50 MB per second, so we'll have 20 partitions. I have to just look for this. Somewhere it is in between these two. Your each partition should handle 10 MB to 50 MB somewhere. Each partition that thing keep in mind. 10 MB to 50 MB per second, each partition should be able to handle. Let's assume that if it is 10 MB and if your application sends 1 GB of data per second, obviously you will be needing 200 partitions. So you will be creating 200 partitions in your cluster. So just forget everything. Just keep in mind that 10 MB to 50 MB. Even 50 MB is too large actually. 10 MB to 50 MB per second per partitions. You should each partition is capable of handling up to 10 MB, 10 MB to 50 MB per second. This you can keep in mind. Each partition should be handling around this much data per second. But I will confirm all these stuffs. I just don't remember these stuffs actually. I will confirm these steps. So once you have, if let's say you are getting, because it is also a bit of a too much. One partition handling 10 MB per second is too much of data. A message size actually we get it from your client application. You can compute the message size. It will be just a string dot size you will say. I mean usually you will say you will have a discussion with your client application. They will be knowing how the size will be. I mean not only it is done programmatically, it also comes as a part of the discussion with the team on the message size. I mean take the concept in mind, keep the concept in mind, then don't go with the numbers here, because I will confirm the numbers whether 10 MB to 50 MB or just 2 MB something, 2 MB or 5 MB. Those things you need to keep in mind. I will reconfirm those things. Based on that, you will be having the number of partitions. So next what we'll see is how the producer works. How the producer works. I mean, before going to the producer, how it works, there are, yeah, we will go there itself. How data is sent, we saw that we had three partitions. We saw that we had three partitions. Let's say Apache log 0, Apache log 1, and Apache log 2. So we had our three partitions, and we had our application here, and our producer was part of our application. So we ran our producer. That producer sends the messages to this broker. Producer will send the message to this broker. Producer will send the message to this broker. Now how the messages are sent? Which message is sent to which broker? How it is determined? Whether the first message is sent to broker 1, second messages is sent to broker 2, third message is sent to broker 3, or how the messages are sent. So that is where partitioners comes into picture. And by default round robin is being used. So round robin is being used. So meaning first message will be sent here, message 2 will be sent here, message 3 will be sent here, message 4 will be sent here, message 5 will be sent here, message 6 will be sent here. Then message 7, message 8, and message 9 will be sent to the broker 3. And so on, the messages are being sent. And that is the recommended one. It is the default is round robin, and it is also the recommended partition. And there are hash partition, and there is explicitly specify partition number. One more is custom partitioner. I mean, all these things are not required because I haven't seen all the other three being used. I have only seen the round robin being used, and it is the default case. But we'll also see how these things are done. So it all depends on your producer API. All these things is uh, your producer API. So you have different constructor for each of the partitioner. Let's see those constructor API. So if we see this producer, so when you create a producer record, this is how you create a producer. You take the message and create the producer record. So this producer record internally calls the constructor, and there are multiple constructors. So as you can see, we are passing the topic name and the actual message, and the actual message will be stored in the value part. It will be stored in the value part, which internally will call another constructor where where one more parameter is set to null. And if you see this constructor is nothing but which is taking three parameters. So internally, this constructor is calling this constructor, which is nothing but a constructor with three parameters, where the middle one is the key which we are setting it to null. So by default, if you specify if you use this constructor, I mean I think there is no default here. If you use this constructor to create a producer record, it will be using a round robin. It will be using the round robin. First messages will be sent to the first broker. If we use this constructor to create a object, if we use this constructor like here shown, some will generate some unique ID. Now if I generate a producer record, if I create the producer record using this API, so we are specifying some key here. We are specifying some key. So it will use this constructor and key will be created. Whenever key is being used, a hash partitioner will be used. Hash partitioner will be used. So what we can say here is no key, no key, a round robin will be used. If you specify the key, hash partitioner will be used. So it will do a hash just like we saw in Spark. Hash on the key and percentage number of partitions. So in Kafka, if there are some 10 partitions, or let's say there are three partitions, in Kafka cluster there are three partitions. So percentage 3 will always give you 0, 1 or 2. So based on the hash value, when we divide it by the 3, whatever remainder we get, we will be sending the data to that partition. So that's how the hash partitioner works. Or we can explicitly specify the partition number. There will be one more. So this is one more constructor. Topic, we have the partition number, key and value. So the partition will be set. So it will be sent to that partition explicitly. Explicitly specify the partition. Sometimes you can also write a custom partitioner. I mean, I will not go into the details of this code, but custom partitioner is also available in the code. So if you open downloads training Kafka producer example, as I said, there are a lot of examples here in this code base. There are a lot of Kafka example, producer example. You can check that as well. So you will see producer example, you will see partitioner here. So we have written some custom partitioner. So this is the sensor producer. It uses custom partitioner. So to specify how to use the custom partitioner, that will be part of the configuration parameter. So these three are mandatory parameters. These three are mandatory parameters. Bootstrap server, key serializer, value serializer. If you want to write a custom partitioner, you have to have the key as partitioner.class and what is your actual where is your code specified sensor partitioner. So if we see the sensor partitioner, so this is where the logic is going to be done. It has to implement the partitioner. It has to implement the partitioner, and we have a this is the logic where you have to write. Partition is the method where you have to write the logic. Let's not worry about the this use case. Usually you will not have any custom partitioner, but if you want, you can go through this. Now, how internally things work. How internally things work. I'll just showcase one diagram here to understand how the things work. So this is the code we saw. So we write this code. We create this producer record. Developer writes this code. So this is the internal producer. Internal what happens. So as soon as you send the message using the send method, which is this I will. As soon as you call this send method, this is what we as a developer write. So internally what all things happen. So very first thing that will happen is serialization will happen. Serialization will happen. After serializing, the partitioner comes into picture. If you can send a string message, you can string a Java object message, JSON object message, and corresponding serializer will be there. Sometimes you have to write your own serializer if you are sending the data in some custom form. So you can write your own serializer. Once it is through the serializer, it will check which partitioner is being used based on which API we have called it. Whether key is specified, if it is not specified, all those things will be checked, and based on that, corresponding partitioner will be used. Either it will be round robin, hash partitioner, or custom partitioner, or explicitly partition number. Based on that, it will be copying that message to its local buffer. It will be copying the message to local buffer. Meaning meaning I will just showcase that here there is something called as batch 0, batch 1, and batch 2. So actually it has to be topic A itself. There was a slight wrong in the diagram. Both are topic A. Both are topic A. So what I'm trying to say here is, so this is your Kafka cluster, I will say. So there is multiple partition. Let's say we have sensor 0, sensor 1, sensor 2, so on. We have somewhere around sensor 20. Let's say there are 20 partitions. Let's say there are 20 partitions. Now your producer is running somewhere. This is your client application. Now what the producer will do is it will have 20 buffers. Let's for simplicity purpose, let's say there are four partitions. Sensor 3, sensor 0, 1, 2, and 3. So there will be four buffers created. Memory buffer. When I say buffer, the RAM is allocated to these buffers. Now producer will determine using which by default, let's say round robin round robin algorithm is being used. So message one, which will be sent to the broker one. This will be broker two. This is broker three. This is broker four. So the producer will not immediately send the messages to the Kafka cluster. It will buffer it in its buffer. Message one will be buffered here. Message two will be buffered here. Message three, message four. Similarly, message five, message six, message seven, message eight, message nine, message 10, message 11, message 12. It will not immediately send the message. It will buffer it in its local memory, and then it will flush these messages to this broker. This is partition 1 buffer, this is partition 2 buffer, partition 3 buffer, partition 4 buffer. So this partition buffer, this buffer will go, the contents of this buffer will be flushed to broker 1. So these messages are one batch. So this is a batch. Let's say it is batch 0. Batch 0 contains message 1, message 2, sorry, message 5, and message 9. So that's how the batches are come. So producer always sends the messages in the form of a batch. Now how often it sends the messages? How often it sends the messages? That things are controlled by some extra configuration parameters. I mean, there is bytes, batch size, and linger millisecond. So if say let's say batch size is 10K and linger milliseconds is 10 milliseconds. So the data will be, or the messages will be accumulated in this buffer until one of the thing, I mean threshold crosses. Either your total messages size is greater than 10K or 10 milliseconds has expired. When one of the thing fires, I mean one of the threshold crosses, data will be flushed to the disk. Data will be flushed to the Kafka cluster from the producer. So that's how the batches comes into picture. So this whenever this is flushed, it will be a batch. Whenever this is flushed, it will have its own batch. This is batch zero. Batch zero of this, for this broker, this will be batch zero. Similarly, next batch one will be sent, batch two will be sent, and so on. So on, messages will be sent in terms of batches. A batch may contain one message, a batch may contain two messages, a batch may contain five messages, a batch may contain, I mean, it's a random number of messages based on your batch size and based on your linger millisecond. For within 10 milliseconds you might have got only one message. Before getting the second message, your 10 millisecond has expired, so that batch will be sent. So that's how the producer works. It may send the messages immediately, or it may accumulate the messages and then send it the messages in one go. I mean, there are reasons when it has to send immediately, and there are reasons when it has to accumulate and send the messages. So I hope these things were clear. So first the serialization will be done, then it will determine which partition it has to be. Based on that, it will be sending to the corresponding buffer. I mean, slightly it is wrongly specified. As and as messages is sent, it will be represented as batch 0. Internally inside a batch 0, you can have multiple messages. Inside batch 1, you can have multiple messages. Inside batch 2, you can have multiple messages. And they will be sent according to the batch size or the linger millisecond. So I hope these things were clear. How the producer internally works. There are certain things we also need to know. Those things are how these configuration parameters plays a role. So these things we'll see tomorrow. So service goals are very important for optimizing Kafka. If you want to optimize Kafka, whether you want to achieve throughput, whether you want to achieve low latency, whether you want to achieve high durability, or whether you want to achieve availability. So based on these things, your your lot of configuration parameter changes. What should be your batch size? What should be the linger millisecond? All those things. So you cannot achieve all the four goals in one use case. You cannot achieve all the four goals. You have to compromise on one of these service goals. If throughput is there, we cannot achieve latency. Sometimes if throughput is there, we cannot achieve durability. So you have to sit with the team, discuss on the application, check what you want to achieve, whether you want to achieve high throughput, whether you want to achieve low latency, whether you want your messages to be highly durable, you don't want to lose the messages, or whether you want your service to be always available. So those things has to be kept in mind while developing a Kafka cluster, or while deploying a Kafka cluster. And that we will see tomorrow. So thanks everybody, and let's continue tomorrow same time.